In this video, we're going to go over vectors, a very important topic in physics that will also apply to all the units that we'll go through. So if you will understand how to properly do vector manipulations and vector operations, you will be so much more confident in all the problems that we'll have throughout this whole year. So in the first part of the video, we'll learn the difference between scalars and vectors. In the second part of the video, we'll learn what is the graphical method for adding vectors. And finally, we will learn a step-by-step instruction on how to add vectors. As I said, this knowledge you will use literally this whole physics course. So it's very, very important. So keep watching, as by the end of this video, you will have a really good understanding of what are vectors and how to do mathematical computations with them. Without further ado, let's start by examining what is a scalar and what is a vector. So a scalar is a quantity that is simply a magnitude, right? So when I say magnitude, I just mean a number, right? A vector is some kind of quantity that has a number, right, or magnitude and a direction. So let's analyze like what these words actually mean, right, by looking at these following quantities in the middle. So we have mass, time, force, velocity, and speed, and we have to either put them as scalars or vectors. So what I want you to think is, for example, mass right here. Can mass have a direction, right? Can you say 5 kilograms to the left or 5 kilograms to the right? Well, not really. It doesn't really make sense for mass to have a direction. So therefore, mass will always be a scalar. What about time? Does time have a direction? No, time also doesn't have direction, right? It doesn't make sense to say 5 minutes to the left or 5 minutes to the right. So therefore, we'll put it with scalars right here. What about force? Although I know we haven't learned about forces yet, right? Does it matter? But can force have a direction? So can you push with the force to the left or to the right or up or down? Well, yes, of course. So force will be a vector, always be a vector quantity. Now, here we have two words that seemingly are the same, right? Velocity and speed. One will be a vector and one will be a scalar. Can you guess which one will be which? So speed will be a scalar. Speed is essentially how fast you're moving without including the direction. So in our cars, we, for example, have speedometers, right? They tell us how fast we're moving, like let's say 50 miles an hour, right? But they don't tell us the direction. So speed will be a scalar. Velocity, on the other hand, will always include the direction. So therefore, it's going to be a vector. So this is definitely not an exhaustive list of all the vectors that we'll have to deal with. There will be a lot of different quantities that are vectors. And in order to understand how to do operations with them, we need to know how to add them together. So firstly, let's talk about how to add vectors graphically. So let's say you have here one vector that is essentially an arrow, right, a line, A, and another vector that is B right here. So how do I add them together? So the method for graphical addition is pretty simple. So you take one of these vectors, doesn't mean which one. Let me take, for example, vector B, and you put it at the end of the first vector, like this. Then you just connect the beginning of the first vector and the end of the second vector, and you connect them with a line. So what it means is the following. For example, if I have a vector in this direction and in this direction, the overall direction will be in this. Now, let's practice on this one. So again, A plus vector B. So for example, again, I can take any vector, but let's say I'll take vector B and I'll put it at the end of vector A, right? So right here, again, very important, not here at the beginning, at the end. And then I'll just connect the beginning of A and the end of B right here. So, for example, if these vectors were to represent a force, right, what this would mean is if I was pushing with the force A and pushing with the force B, the overall force would be in this direction. Finally, what about if I subtract them together? So subtracting is also not that hard. What minus B means is that we just have to, before we add them, I have to flip the direction of B. So instead of in this direction, I flip this, and the other method is basically the same. I take this vector and I add it to A, and then connect the beginning of the first vector and the end of the second vector like this. So that's going to be my resultant. Great. However, most of the time, we will add the vectors algebraically, right? Because we actually need a numbers that correspond to it, right? How long is this line? So in order to add the vectors algebraically, we're always going to follow the same steps. So here's the method for it. So for each of the vectors, firstly, we'll determine the x and the y components. The way we'll do this is by solving right triangles. So for example, if this is the vector, right, we will determine the x and the y components by doing essentially sine and cosine. So sine of theta is equal to opposite side y over, let's call this d, like we did in the formula, over d. Cosine theta, right, cosine is adjacent side over hypotenuse, so x over d. So that's where these formulas come from. X is equal to d cosine theta and y is equal to d sine theta. Once we determine all the x and the y components to our trigonometry, we'll have to assign the signs. What I mean by that is, for example, if our vector is, let's say, for example, in this direction, right here, this component has a negative sign because it's to the left. So we usually take to the left as a negative direction and downward as a negative direction as well. And we'll have to add these signs as basically essentially manually. So once you found the x and y components, I just want you to revise your vector one more time and seeing if you need to add negatives to any of those components. Finally, we will sum all the x components and all the y components. So if we have, for example, two vectors, right, you will sum their x components separately and you will sum their y components separately. Sorry, my y's look like asses. Finally, once we have the total x and the total y component, we'll find the magnitude of the resultant force. So essentially, if you have a total x and the total y component, what you're doing is you're finding the hypotenuse, right? We call this resultant force. So overall vector is called the resultant. So using the Pythagorean theorem, right, we find r, and then using tangent, we can find expression for the angle theta. Now, let's see how these steps apply to solving a real world, basically, vector problem. So on the next page, we have these two vectors and we have to find the resultant. We have this 5 Newton force at 30 degrees and 10 Newton force at 20 degrees. So the first step is going to be finding the x and the y components. So let's do just that. I'm going to make right triangles right here. So x1, y1, and x2, y2. So let's take a look. Let's firstly start by drawing, right? Sine of 30 degrees is going to be, so sine is going to be opposite y1 over the hypotenuse 5. So in other words, y1 is going to be 5 times sine 30. Similarly, cosine of 30 degrees is going to be x1 over 5, or x1 is going to be 5 times cosine 30. This will be approximately 2.5, or exactly 2.5. This will be approximately 4.33. Great, so now we just found x and y components of the first vector. As you can guess, we can also find x and y components of the second vector in the same way. I'm going to multiply 10 times sine of 20 and 10 times cosine of 20 over here. So this will be 3.4 and 9.4. Great. Now, do you remember what was the second method? The second step, right, was to revise the signs. Well, this line is to the right, so it's okay, it should be positive. This line is up, so it also should be positive. And this one as well, it's to the right and up, so all of them especially are positive, right? But if one of those components was to the left or down, we would have to add negative signs at this step. Very important, guys. Okay, so now the third step, or in this case, I guess we didn't have to add the signs, is to find the total x and the total y components. So the total x components will be 4.33 plus 9.4, or which will be 13.73. What about the total y component? It's going to be 2.5 times 3.4. Great. Now, let's take a look. The final step, right, is going to combine this the total x component and the total y component, right? Which, by the way, I wrote them exactly like this, to the right and up, because both of them are positive, right? So we're going to combine them into resultant. So the resultant is going to be square root of x. This will come from the Pythagorean theorem, right? So if we plug in our numbers, we have the final answer for resultant as 15. Great. Now, so this is the length of the final vector, and let's also find the direction. So the direction here, theta, we can find using tangent as yt over xt, right? Or y was 5.9 and 13.73. So from here, theta, if I take inverse tan of both sides, is going to be this, 5.9. If you're wondering how to calculate this on your calculator, you have to hit second and then tangent to have inverse tangent, and you should get an 23.25 degrees. If you didn't get this exact answer, maybe you have to check that your calculator, you have to go to mode and check that your calculator is in degrees. But just like this, we found the total resultant vector and essentially the direction, right, or the angle. Great. So thank you guys for watching. Make sure that you do at least 1 or 2 vector problems on your own to make sure that you understand it. Keep watching these videos and keep practicing on your way to an A. Thank you guys for watching.